Hey everybody, it's Troy. Just thought I would put together another lecture here. And this one is going to be about network design and some of the things that we need to take into consideration when we're doing a design. Um, Network design encompasses several categories. The first of which is you need to be able to articulate or at least have an understanding of what it is your company does to make money. Are you a manufacturing company, software company, shipping company? And once you know what it is that your company does for work and how they make money, then you also have to be able to define where the IT group fits into that. How do you support them in their money-making endeavors? As an IT group, we're really more of what they would call in accounting as a liability. Not that we're, that we're reckless or anything. A liability in the sense that we cost the company money, we don't make the company money. So we really have to work hard at being able to justify our purpose and what we're doing for the company and for as far as the IT group, how we're helping the company make money. So that's the first thing that you have to be able to do. The second thing is when you're designing a network, there's a few things that are going to restrict what you do within a network. And one of the first things that you're going to find is that within a network, you're going to be restricted by the layout of the office. So if you're doing a network from the ground up and you walk in, your company's decided on an office to lease, you're going to be restricted in how that gets set up simply by the physical nature of the office. The physical nature of the office will determine where your IDF goes, where the MDF is, how you're going to run cable, how you're going to set up your cubicles, all that kind of stuff. If you're already in an office, then you may not be designing a network from the ground up. You might be revamping part of it or adding to it. Say you need better wireless access points, or you need to install security cameras, or you need to put in more data outlets because your company's growing. Those are some of the things that you're going to be dealing with when you go into an office that's already set up. Let's open up my little notes here real quick. Excuse me. So you also need to be able to figure out how you're going to leverage the current assets that you have as the IT group. So, you may have X number of servers. They might be, maybe a couple of them are 10 or 15 years old, so they've really reached their end of life quite a while ago. How are you going to leverage the stuff that you have and balance that with what you need? And that all comes down to network design as well. Most of the time a company is not going to be able to just give you all the money that you want to build up a network or to replace everything that there is. So you have to be able to prioritize what is it that we really need, what is it that we can get rid of, what is it that we can keep and either repurpose it or make it work for the mission that we have right now until we can get something better. Okay. And so network design involves that. And also you have to be able to think of other contingencies that you may have to deal with. For example, you might have remote users. So if you have remote users, you have to think along the lines of, I have to be able to have a VPN system of some type for them to be able to log on to the private network and do their work. We saw this with the COVID-19 when everybody all of a sudden started working from home. There were several companies that didn't have the capacity for all of their workers to VPN in at one time. So these kinds of things have to be taken into consideration. And it's going to be up to you in the IT department to be able to do that. And that's part of the network design. So some of the other things you're going to want to do would be the network diagramming, and you guys have done that. And network diagramming comes in a couple of different flavors, if you will. You have a logical diagram, you have the physical diagram, and then you have other documentation that supports both of those items. And I want to take a look at that documentation right now, if we can. Okay. So here we're looking at a logical diagram. This diagram is pretty in depth, but it's in depth simply because of the size of the diagram and the size of the requirements that it has. You'll notice it doesn't go super specific or exact how the layout is of an office. It just shows you that you have a wide area network, 2 offices. They show how they connect. They show the individual firewalls. They show the internal IP addresses. They show DMZ, what those address ranges are going to be. They show what they've put into the DMZ. They show on this side you can see wireless access points. And then over here, wireless access points. You can also see they show that they've got their PCs on a DHCP and such. So this is the type of logical diagram. This is a 10,000 foot view, which we've talked about already. Other types of network diagrams would be like these. Let's see. I want to open this one as a picture so that you can see it better. Alright, so this is a physical diagram. If you take a look at this, you can see that in this diagram you see that they have red and white and they're alternating. Okay, so that's showing you each place where there's data and voice capabilities in all of these different areas, and they're numbered and labeled so it's easy for you to access where these cables are going. You know that John sits at D14, so when you look at your documentation, you look at your map, you know that D14 is here, and the cable's in the server room. Here's your server room right here. Those cables are plugged into switch 2 port 24. Okay, so this is a detailed physical diagram. This is one that you would work off of if you had an office, you had a floor plan, and things were, they came in and said, okay, we're going to put cubicles here, here, and here. We have conference rooms, another conference room. We have cameras. We have offices. We have elevators. We have ingress and egress sites here. There's a door here. There's a door here. And of course you'd want to cover those with some kind of a camera. Same with the server room. You'd want to put a camera of some type in there, just so that you can see what's happening and keep control. That's part of the physical security of your network, as well as how do people come in and leave your office. Alright, that's all part of network design. Do people, is the door always open or is it always locked? Do they have to get buzzed in? Are they met by someone at the door? Is there a camera there? Do they have to sign in? Do they have to be escorted? These are all things that IT is going to be responsible for. The onus always seems to fall to the IT department, so you have to be prepared for that. Let's see. Here's another part of it. Here's another physical diagram. This is of the other office that they did. That's laid out the same way. Never mind. Okay, so let's take a look at this. Now, once you've completed your physical diagram, okay, the next thing you want to do is get down a little bit deeper and in more detail. And for those of you who've never seen anything like this, this is a server rack, and the server rack is going to have all kinds of stuff in it. It'll have servers, it'll have, it could have switches, it could have a NAS for, network storage. It could have uninterrupted power supplies. It could have really anything that you can mount inside a rack is eligible to go into one. So if you look in this rack, they have several patch panels. Okay, and that's a patch panel. I'm sure you guys have taken cabling. If you haven't taken it, patch panel is simply where the cable that comes into your office, that's the place where it physically connects it's punched down into the back of a piece of hardware, and then you plug that in and plug it into a switch, and that's how your network works. You might have a power strip. You can see here we have several switches. Here's a 48 port switch, 48 port PoE switch, which is power over Ethernet. You're going to have those for wireless access points, cameras, even if you're doing VoIP and stuff, you may need that as well for that. Okay, and then they have core switches, a management switch, firewall. Here's their file print server. They made it physical, and then they have 2 UPSs here at the bottom. So here's a different layout for server racks. You can see again they represent the size that the server rack is. Server racks are usually done in what are called U's or units, and most of the time they're like 42, which means that there are 42 spots where things can go. But a server might be a 4U server, so it takes up 4 of those, or a 2U. Okay, so you have to kind of plan how you're going to set up your server rack. And as you saw from the other one that we were just looking at, you always want to make sure that you put your UPS at the bottom because they're really heavy. Alright, so this is a picture of what the back of an ASA or a firewall looks like. Okay, so you can see that this light blue cable you see, that's for your terminal, so you can log into it. And then the 0, which is this one right here, that is our main internet cable. That's coming in, so that's all of our data and stuff that's coming in. It's all coming through this port. Number 1, that's going to be for our inside network. Number 2, that's our DMZ. Number 5 is guest Wi-Fi. Right below that, you see more cables and things, and that's a switch that's underneath it. Another example of a logical diagram for a big area. This is what a server rack looks like in real life. Excuse me. You can see that starting up here at the top in this server rack, you have this is a NAS. These two things right here. This is where backups might be kept. This is a virtual server or virtual host, and this is a virtual host. And then these are physical servers as we come down that have different uses. They could be used as virtual hosts or an actual physical, depending on what you need. Here, this is a slide-out keyboard and monitor, so that at any given time, I can log into any of these servers and actually be inside of it as opposed to just remoting into it. Sometimes you can't remote into a server, especially if something is jacked up in it and it's not recognizing that it should be on your network. Then you can't remote into it. Then you have a UPS down here. So this is the back of these servers. I want you to take note as we start talking about this, because this is something you need to be aware of. Right here you see that this server has 2 Ethernet cables plugged into it. And this server also has 2 Ethernet cables plugged into it. But the one below it only has 1 Ethernet cable plugged into it. So the reason that it looks like this is that these 2 servers right here are virtual hosts. So this is where you would have virtual servers that are being hosted, would be on these 2 machines. And each machine has an internal network access point and a DMZ access point. Alright? Because you're going to have both types of virtual servers on a machine, and they have to be able to be able to get into those VLANs and speak with the machines that are there. Okay. Up top you see the NAS again. Also notice you have dual power supplies, and these are hot swappable, meaning you can just pull one out without turning the machine off and replace it. In fact, this one right here on this side where my mouse is, this actually went out, and I pulled it. Had to wait for a new one to come in. Once it came in, I was able to just plug it back in and keep on going with it. What you're looking at here, as far as network design goes, this is an interesting thing. This is the IDF. So this is your individual demarcation point. And you'll notice all these white cables that are in the back. And you'll notice all of the black cables going from these tan boxes up. Let me explain what you're looking at real quick. So these are all the cables that are in our punch panel, which is right here. Okay, these are all these are punch panel cables for this and for this. The top one, this is data, and then this, like it says right here, is all voice. This is an older setup that my company had. They just couldn't afford to go to VoIP yet, so we had to do it this way. All of these cables punch into here, okay, and then they run up into the ceiling and out, and then spread out as they go across the office. And in our office, we did it through the ceiling. Sometimes they go through the floor. You'll feel like a false floor, and they run the cables under it. A lot of the labs at UVU have a false floor, and that's why you can like pull those little caps off and look down in there and see like power plugs and things like that. And this is also a good cable management job. My boss was very particular about it, so these are all 1-foot patch cables, so we didn't have a big mess. This red cable is to it's a thermometer for the room, so that that we hooked into the network, so that if the room got too hot, it would ping us and let us know what was happening. And then this, of course, is for the phone that goes up here into here. You'll notice that some of the things here are labeled. Right here, this is where our main internet comes in and is patched. And is patched in, and then we run a cable from the patch panel up to the router firewall. Okay. And these are things that you're going to have to deal with as you design a network. And that's deciding, how do you want to divide things up? How do you want to make things work or not work? Or how are you going to keep things organized? So, something else I wanted to show you. If you look on these cables, you'll see this white tape. And you really can't see because just the way they're set up right now. But on this, it will have it'll have the name of the server as well as what that line is for. Is it internal or is it DMZ? So that we know what we have in each one of these. And the way to do it, and the way to make sure that you always have things done correctly, is to have all of your cables marked as to what they are and what they're doing. Alright? It's so important to have that. If you look back at this picture, you'll notice these have tags on them. And what these tags say, this is going to say guest Wi-Fi. And this one's going to say DMZ. This one's going to say internet. This one's going to say inside. And then if you look down here, this is it says firewall DMZ. So it's going from here up to here, or up to 2, which is right there. That's where that cable goes. And then this cable's labeled phone. This one right here will be labeled as the thermometer. And you want to do that so that you can have ease of going in there and finding stuff. Now, you mark the cables that have to be there and that aren't going anywhere. Individual cables you don't mark, but you do document them. And the way you document those is on something like this. And let me go through this document really quickly. So I've created 3 tabs on here. Ideally, these would probably be 3 completely separate documents. This one is our IP address document. So when we look at this document, we see all the IP addresses that we have. And then next to the IP address, we name the item that is currently occupying that IP address. We give them names that make sense. We use a naming convention of some type that we can use for here on and that makes sense. So in here I put DE, saying that this office is in Delaware. So that's the postal code for Delaware, DE. And then, as you see up here, DEFW1. Well, I'm pretty sure everybody can figure out that that's the Delaware Firewall 1. If we got a second one, or if we replace this one, we would call it DEFW2, showing that it's the second one. And we would never reuse these names. We would just keep incrementing as we went on, as we replaced things. Then you'll see we have switches, wireless access points, cameras, printers. I threw some file share servers in there, utility servers, web servers. I did 2 virtual hosts here. Also, you'll notice here it says previous tenant, and I don't have anything there, but what this does is that if you need an IP address and there was some type of an asset that had that IP address before, but it's not there anymore, it's always a good idea to just make a note in here that previously this was DE printer 1 and now it's going to be something else. The reason you do that is in case that there's some mix-up with people, or they have code that's they have hard addresses in the code, and it messes somebody up somewhere along the line. So it's always a good idea to put who the previous tenant was, right? Just so you have an idea of, oh, whoops, we made a mistake. We better back this one out, and then we know who to give the address back to, or whatever it might be. Now I put reserved for in this column on the far right, and this just kind of helped me stay organized so that I keep like objects together. Okay, it doesn't always work out that all the like objects will be together, but it's a good idea to try. So what I've done is I've given 1 to 30 as static IP addresses. These are ones that we can assign to a specific server or wireless access point, camera, switch, whatever it is, we can assign it. Once you get to 31, so 31 down to 49, these are to be decided. We don't know what we're going to do with these yet, but they're still open, right, for static addresses. Once you get to 49, that's your last static address. From 50 to the rest of the to the end of the network is going to be given to our DHCP, so it can lease those addresses out. So if it's a DHCP address and you assign it statically to something, you could cause a real problem, because DHCP might try to lease that address out to someone, and you're going to get an IP address conflict, and then you have to go back through and try to figure out what happened, and it's always a nightmare. So it's good to have a document you can see. These are the addresses that I have set up for static. These are the ones that we can't touch because they're DHCP. Okay? Again, this isn't a hard, fast rule. This is just an idea of what you could do to help you stay organized. Now with switch ports, this is a really good place, and this is something a lot of people don't do, but I really think it's smart. And it's a map, if you will. It's in Excel, but it tells me every single port on a switch, what does that port support? In other words, what's plugged into port number 1? What's plugged into port number 2, 3, 4, 5? And also, what VLAN is it on? Is it on VLAN 1? Is it on VLAN 10? Is it on VLAN 50? Right? You're giving VLANs numbers. On this one, say our VLAN is number 1 is internal and 10 is DMZ. Okay? And the reason you number it is because that's how you set it up in a switch, is by numbers. So that's why you give it a number. And then for mapping, if you remember back to the picture we looked at of the back of this server, remember I told you, you have these two Ethernet cables that are coming out, and one is DMZ and one is internal, and it tells you right here which port it's plugged into. Well, what you want to do is you want to go, and on your list you want to say, okay, this server, say this is our DE VM host 1, alright? And you would map so that it would be, okay, this cable is going to port X in our switch, and on our computer it's plugged into port 0, and this one's going to port Y, and it's plugged into port 1. That way, if you ever have to disconnect everything and pull it out to do work on it, you know which cable is supposed to be plugged into which port. And it also helps you keep things straight in case you have a problem and you need to know, okay, so what port do we have our internal network on. Well, here we could say, okay, so this is DE VM1, all right, and we could say that this is port 0. That's where we have that Ethernet cable plugged into. And here we could say this is plugged into port 1. Okay, let me put a 1 in there. So if you look at that, if you remember, VLAN number 1 is our private network, and VLAN 10 is DMZ. So now when I look at this, I can say, oh, okay, so my virtual host has 2 Ethernet cables, and it's in port 0 and port 1. Port 0 is mapped to our VLAN number 1, and port 1 in the back is mapped to DMZ. And then I also know that these are the port numbers that correspond with the switch that it's in. It's just a way to make sure that you have documentation of every single thing that's going on. It's also good to print these out and then hang them up in the server room, so you can just go right down the list and see, oh, okay, so let me look. I have port 24 open. Nothing's plugged into it, and you go down the list and see, oh, wait a minute. This is supposed to, this server XYZ is supposed to be plugged into it. Why is it not plugged into it? Oh, well, we retired that. Well, then we need to update our documentation, right? And I think that that's so important that you do this. The other important thing is to make sure that you label all of the data and electrical ports and phone ports out in the office area, so that you know what's what. You don't just start plugging stuff in and hoping things work. And if something is bad, if a port switch goes bad or an outlet goes bad, you have to label it. If you're not going to fix it because it costs more money than it's worth, you still need to label it. So somebody who comes behind you doesn't try to use it and ends up not being able to use it and has to spend hours troubleshooting it to figure out what's going on. This will also help you when you go to troubleshoot. All right. So if John, that works in the design group, he says that his internet's not working and you're having a problem, you can go in to your server room and look at the port on the switch where his internet is connected, and you can look and see, are the lights blinking on it? That shows that data's coming through. If they're not blinking, you might have a bad cable, you might have a dead port, but it helps you to know. You don't have to go in and try to decipher where everything is. You have a list, you have a document that tells you where everything's at. So these are just some things you have to take into consideration when you're doing network design. I hope this is helpful. As always, I hope you guys have a great night. Stay safe, and I'll talk to you soon. Bye-bye.